A transparent sealed box is said to have something inside, but no one can see it. Sana thought that it's full of air particles. John believes that it isn't. It's empty. A perfect vacuum. Liam believes that there's no such thing as empty space. Particles are everywhere. Who do you agree with and why? Can space ever be truly empty? Matter is everywhere. It is anything that has mass and occupies space, and everything around you has mass and takes up space. Matter can also be identified based on how it is described by the particulate theory of matter, which states that all matter is composed of particles which are always moving, and they have spaces and forces of attraction between them. How do scientists know this? Because of experimental evidence such as Brownian motion and diffusion. The particles that make up matter include atoms. These are the smallest particles of matter. Molecules. These are chemically combined elements. And ions. These are charged particles of matter. The particles of matter can exist in different states, and depending on the state they exist in, they show unique particle movement due to the arrangement of the particles and the force of attraction between them. The particles of matter can exist in the solid state, where they are orderly and closely arranged. The force of attraction between the particles is strong, keeping them close together. As such, the particles do not move much, but instead, they vibrate in their fixed places. Due to the limited movement of solid particles, they do not have much kinetic energy. Solid particles have a definite shape and volume and are not compressible as the particles are already close enough. The particles of matter can also exist as liquids. In the liquid state, particles are randomly arranged with small spaces between them, but some of the particles still touch each other. With a little more space between liquid particles than in solids, liquid particles have a little weaker force of attraction between the particles than in solids. The particles have a little more room for movement, so they have a little more kinetic energy and move a little more than in solids as they slide past each other. The particles are still relatively close and are therefore not easily compressed. Liquids have a definite volume, but take the shapes of spaces they occupy. The particles of matter can exist in the gaseous state. In this state, the particles are widely spaced from each other and are not orderly arranged. Having large spaces between the particles means that they are not held close to each other by a strong force of attraction, and with that much space between the particles are free to move a lot with a lot of kinetic energy. Gases also take the shapes of whatever spaces they occupy, and with the space that exists between the particles, they are easily brought together when they are compressed. If particles are in one state of matter, they can exist in another state, depending on if they are heated or cooled. If solid particles are heated, they can enter the liquid state by melting, or the gaseous state by sublimation. If liquid particles are heated, they can become gases by evaporation or boiling. And if they are cooled, they can become solids by freezing. Gas particles are cooled to become liquids by condensation, or solids by deposition. Now that we understand the particulate nature of matter, tiny particles constantly moving, spreading out, and filling space, let's revisit the sealed box. What could be inside? If we know matter is made of particles, and we know gases spread out to fill all available spaces, and particles don't just disappear, then what should be inside the box? Is it full of invisible gas particles? Is it truly empty? Or is the truth somewhere in between? Even though we can't see the particles of air, they're still matter. They have masses, take up space, and move around freely. A normal sealed box in an ordinary environment will almost always contain air particles. To remove them, you'd need some special equipment like a vacuum pump. And even then, a perfect vacuum is nearly impossible to achieve. So, there you have it. What looked like an empty box turned out to be a world full of unseen particles. And that's the magic of matter. The more we learn to look beyond what our eyes can see, the more incredible the universe becomes. For more insight from Sci Insight, please like and subscribe. Stay tuned until next time.